Go on to the next part of the challenge. Okay, now I'd like you to create a time plot that depends on that. How are we going to create a time plot that depends on that? You folks tell me. What do I do to create a time plot? People? Okay. Okay, good. So, folks, over in the right panel. Yeah, it's down here in analysis. Okay, so I'd like you to go go grab something in from time plot. Okay, time plot. Now in the time plot, so this we'll call it plot cumulative infections. Okay, so we've just dragged that in time plot. Whoop, and I made it plot cumulative infections. Let's make it, well, we can leave the defaults here. We want it to update data automatically. Let's add a data item to it. To display something, we're going to have to add a data item. What value will it report? Yeah, cumulative infection count, okay? That's the value it will report. And now, ladies and gentlemen, we can have this infection count here, and here we have this cumulative number. Now, why is it scrolling so much? Well, we set the time associated with it to be very small, so it scrolls off too quickly. Let's set it so that this time plot actually can display a large number of values, a time window of 1,000, and it can display, say, 1,000 latest samples, given that it's updating once a time unit automatically. Okay, so so we're going to display this, and okay, who needs a professor help? Okay, professor help. Okay, the professor help is on its way. Yes. Okay. Okay. So in this, you could call it, plot cumulative or whatever, but the key thing you have to do is to add data item and refer it to this cumulative number. Okay, it's plotting a value and refer it to cumulative infection count. Okay. Yeah. Okay. Did I say that? Where is this occurring? Oh, yeah, okay. So, so population size here. Is it possible that this is a double now? Yeah, it's a double for some reason. Maybe that changed somehow, but that's weird. It spontaneously changed. So yeah, it's working. It's working. Yeah. Okay. Maybe you hit something accidentally.
I upload the file here even now without any change.
Really?
I'm not sure.
Okay, I'd like to see that. Do you think we should have sent it via Instagram?
No, we received it and it works.
What's that?
Yeah, we received the download. We downloaded the file.
But it didn't work?
It works, yeah, it's fine.
Okay. 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 Folks, what do you see there? This is worth pausing on for just a moment. What do you see here? In terms of the system dynamics, speaking in a generic way, what do you actually see? Like, what's going on? What sort of curve is this? It starts kind of slow, and then it goes up and becomes sort of S-shaped. It's like a logistics curve. It's a logistic curve. So it's like an S-shaped curve. There's only a few infectives. It starts to take off. It rises exponentially, and then it sort of does it. This is the number of infectives. It rises up. What dictates this long, slow tail here? What do you think dictates the tail and the number of infectives? Recovery. Yeah. This is, ladies and gentlemen, this in an agent-based context is basically the same stock and flow dynamics we saw with stock and flow models. We can understand it in terms of, by framing it in terms of stocks and flows. here we have, and maybe I'll phrase this early on. I'm not saying that the results would be the same as if we simulate it with stocks and flows. What I'm saying is that in a model such as this, we can appreciate its dynamics over time by remembering back our understanding of stocks and flows. So here, ladies and gentlemen, why is this rising quickly? Why is this rising quickly early on, the number of infectives? The number of infectives? Yeah, and they're spreading. Okay, why does it peak out? At that peak, what is true? If we consider a given person,
Every person could infect just one.
yeah, on average, an infectious person infects on average one person before they recover. Alternatively, ladies and gentlemen, not just lady, alternatively, we could think of it as the rate of recoveries, the number of people per unit time who are recovering is equal at that peak to the rate of what? Getting infectives, and that's why it turns around there. We could think in terms of those stocks and flows here. Let's continue on. So it's coming down. Why is it coming down here? Okay, there's recoveries going on, and as recoveries go on, there's fewer and fewer infectives, and with fewer infectives, there's fewer new infections taking place, and there's fewer susceptibles around to infect anymore. In fact, there's no susceptibles around to infect anymore. So largely what's going on here, ladies and gentlemen, is a recovery dictated by nothing more or less than the recovery rate of people in the population. Ladies and gentlemen, like what sort of curve here does this remind you? It's a curve we saw with great, perhaps, fondness some weeks ago. What sort of curve is this? Well, I covered that up. What sort of curve? It's like a first-order delay. It's like people are recovering according to a first-order delay. Ladies and gentlemen, I'd like you to go to person. Could there be a first-order delay associated with this? A sort of chance per unit time of recovery? Let's go look at, do you see something there? What do you see? It's a rate just like in the first-order delay. They have a certain chance per unit time of recovering. What is that chance per unit time? 1% per unit time. Ladies and gentlemen, if we had changed that to be a timeout transition, would it be a different dynamics? I don't want you to do this, but I will do it for you. I will do it in front of you. Suppose I made it a timeout with a timeout of 100. Do you think it'll be different? Okay. So ladies and gentlemen, let us go watch the stock and flow dynamics when we have a timeout transition for recovery. Okay, we largely see the same thing going up and now we're getting a situation where the rate of which people are getting infected is getting close to the rate at where they're recovering, so it's sort of starting to max out, right? Okay. Oh man. It's wow. Why is that? Why is it going off the charts? Why is it off the charts now? Oh my gosh. Yes. It's actually on the chart. It's just at the very top of the chart. Okay. Now, look what's happening. Is it going to be a different dynamic, do you think? So now we have a much more defined time. It's not dragged out with some people take a long time to recover, some people take a short time. Now, people are taking a very defined time sick, and so you don't have that long tail associated with the first order delay. Eh? I wanna highlight the fact, ladies and gentlemen, that the average time to recovery between these two cases, timeout of 100 and this rate, which of those has a longer average time to recover? They're the same, but very different dynamics associated with it. Very different. Okay, so here, ladies and gentlemen, we've seen in stock and flow terms some of these dynamics associated with this agent-based model.